Welcome to Mrs. Miller's notes for her pre-calculus class. These are the notes for section 6.3, day 1, entitled Trigonometric Functions of Angles. And today we're going to talk about how to deal with trigonometric functions of angles and whether or not they're positive and negative. And then we're going to evaluate a trigonometric function of any angle. And so we're just going to be doing these top two objectives there. Sorry about that. I wasn't in my inking mode yet. There we go. So we're just going to do those top two objectives for today. Okay, so some of the stuff in the beginning is going to be a little bit of review. You know that you can take a triangle, like they have drawn here, a right triangle, and you can position it so that it is in line with your x-axis and your y-axis, or so that it's in line with your unit circle. Okay. And then if you go over x and up y, you get to this point. So this is your adjacent side to your angle, the x-axis is. The y is going to be the opposite side. And then the r, the radius of the circle, would be your hypotenuse of your triangle. Okay, so we've known that. We did that in the previous chapter with the unit circle. We drew in our reference triangles. So instead of remembering our trig functions as sine is going to be opposite over hypotenuse, cosine is going to be adjacent over hypotenuse, tangent is going to be opposite over adjacent, instead of remembering those ratios, we can remember them as y over r, x over r, and y over x. Okay, and again, r is just that radius or the hypotenuse. So it's still the opposite over the hypotenuse, or the adjacent over the hypotenuse, or the opposite over the adjacent. It's still the same concepts, it's just now with different variables instead of the words in those locations for our ratios. Okay, so this table has all of the ratios there with the x's and the y's and the r's, and it's all based on the Pythagorean theorem and the distance formula. Okay, so make reference to this information as well. Remember, sine and cosecant are still inverses, cosine and secant, and then tangent and cotangent, they're still inverses. Okay. Remember, tangent, you can think of that as sine over cosine, and cotangent is still cosine over sine. Okay. So this is just another way to represent these 6 trig functions on more of an axis type of mentality. But we've already been doing that with the unit circle in the previous chapter, so it's the same information, it's just represented in a slightly different way. Now, the one thing we have to remember is that the trig functions might be undefined when the denominator of any of those ratios is going to be 0. So if you have an x or a y or an r value that's 0, then if that 0 is in the denominator, that function will be undefined. Okay, and they give those a fancy name. They call them the quadrantal angles. Okay, so those are the angles that are coterminal on the coordinates of the axes. So if you see that vocabulary word in your homework, that's what they're talking about. Now, it's also important to remember that this point that they're referring to could be anywhere of any length on the circle or the radius. Okay, so you don't just have to have a radius of 1 anymore. You can have a radius of 2 or 3 or 99.4. Okay, so these ratios that we're dealing with aren't necessarily dependent upon the point. They're dependent upon the angles. Okay, so that just helps us solve more stuff, is what that means. Now, as we're going through our quadrants, we've already talked about this information and this information. You've seen this chart before in the previous chapter. And remember, what it all comes down to is what I've been telling you about where each trig function and its inverse are positive or negative. Okay? All of the trig functions and the inverses are going to be positive in the first quadrant. Only sine and cosecant are going to be positive in the second quadrant. Tangent and cotangent are going to be positive in the third quadrant. And then cosine and secant are going to be positive in the fourth quadrant. Okay, so that's A, S, T, C. So that's all students take calculus. So we've been talking about that with the previous chapter as well to help you remember what trig functions are positive and negative. So it still applies for this section too. Okay, so here they want you to evaluate some trig functions for a given angle. We've done this before, we just haven't done it with degrees so much on the unit circle as we have with radians. Okay, in chapter 5, they gave you a radian measurement like the cosine of pi over 4. Well, we're still going to do that. We can still make reference to our unit circle. They just give us degrees now. And if you want to convert the degrees into radians, you can. But sometimes it's easier to draw or think of where the degrees are on our unit circle or around our axes than it is the radians. Okay, so remember to go all the way around the axis or around this unit circle. That's 360 degrees. We want to go 135 of them. So 135 degrees gets you right about here. Now it's good to know how many degrees you have to go left to get back to the axis. That's our reference angle. And to get back to that axis, you'd have to go 45 degrees. So that basically tells you that this terminal side right here is going to have the same measurements as a 45-degree angle in the first quadrant. Okay? And to evaluate the cosine of 135, we need the terminal point. Okay, so the terminal point in the first quadrant for 45 degrees is the same as pi over 4, and that's where we have the square root 2 over 2 and square root 2 over 2. Now remember, cosine is your x's and sine is your y's in your ordered pair. So we want the cosine of 135 degrees. So we're going to look at this terminal point. The cosine is the square root 2 over 2, but we're in the second quadrant. And in the second quadrant, all students take calculus. Only sine is positive in the second quadrant. So if we're evaluating the cosine, we have to make it negative. So very similar to what we've done in the past, you're just dealing with a degree measurement now instead of with a radian measurement. Okay? So for part B here, we have the tangent of 390 degrees. 390 is way bigger than 360, so that means we've gone around the unit circle one whole time, 360 degrees, and then we've got another 30 degrees, because 390 minus 360 is going to get you 30. So we're dealing with a 30-degree angle right here, and we're in the first quadrant. Okay, so that 30-degree angle, that's the same as pi over 6, and that terminal point was square root 3 over 2, and then 1/2. And if we're dealing with the first quadrant, remember all students take calculus. Everything's positive in that first quadrant. Okay? So sine, tangent, and cosine are all positive there. Now tangent, remember, is, whoops, sine over cosine. So in my ordered pair, I have my cosine value first and then my sine. So if I'm dealing with tangent, where I've got sine over cosine, I have to do 1/2 over square root 3 over 2. Can't leave it like that though. I can't have a complex fraction. So I need to multiply by my reciprocal, which will cancel everything out in my denominator there. And then the 2's will cancel here. So I have 1 over the square root of 3. But I can't leave it like that either. I have to rationalize my denominator. So I'll have the square root of 3 over 3. And it's going to be positive because it's in the first quadrant. So it's really good that we went through chapter 5 first before we did chapter 6 because now you have that first quadrant and all your terminal points memorized, hopefully. So you can still use that methodology to do these types of problems, even when they give you degrees instead of radians. Now, we were talking about reference angles when we were doing the last example. You know what a reference angle is. It's basically how far you have to go to get back to the x-axis. So if you have an angle here, this measurement here is your reference angle. Okay? And they have lots of pictures here. Okay, there's your terminal side of your angle. So your reference angle is this distance back to the axis. Here, if you're in the second quadrant, it's that distance to go down to the x-axis again. If you're in the third quadrant, it's that distance to go up to get back to the x-axis. If you're in the fourth quadrant, again, it's that distance to go up to get back to the x-axis. So that reference angle is always how far you are away from the x-axis. It's how far you have to have left to go, either to keep going down to it or up to it. Okay, so find the reference angle. They're going to have you do a couple problems like this in the homework just to practice, just to refresh your memory on a reference angle. And again, they're going to give you some measurements in radians and some in degrees. Okay, so we've done this before with the radians. I would draw a nice little picture. Remember, if it's 5 pi over 3, that means this top semicircle of your unit circle has been chopped into 3 sections. Okay, and same thing on the bottom. That bottom portion has been chopped into 3 sections. So we're going to go 5 of them. 1, 2, 3, 4, 5. So we're right here. This is where we're ending. That's our 5 pi over 3. Now our reference angle is how far we have to keep going to get back to the x-axis. So I'd have to go another pi over 3. Okay. Now for part B, we've got 870 degrees. So that means I'm going to have to do some trips around the unit circle. Okay. So if I do 870 minus 360, that means I'm going to go one time around the unit circle. I still have 510 degrees left. So if I do 510 minus 360, that means I'm going to keep going around a second time. Now I have 150 degrees left to go. Okay, 150 degrees, now I know where I can draw that. I'm going to go almost all the way to the x-axis. Okay, so there's my 870 degrees, but I'm finding the reference angle, so that's how much I'd have to keep going to get back to the x-axis. Well, you know the x-axis represents 180 degrees, so 180 degrees minus 150 gets you 30 degrees left over that you'd have to go. So that's your reference angle. And again, we want to know those reference angles because that tells us what angle in the first quadrant we're working with, can tell us our terminal points, and then all we have to do is change the signs on those terminal points in order to evaluate cosine or sine or tangents for those values. Okay? So again, that's what we're going to do in our next example here. And they give you some steps to follow as a guideline. But really, the best way to do these is the way that we've just did them for example 1, even. Okay? But in example 1, we had degrees. Now we have radians. But we've done this before with radians, okay? You might see some that are a little more challenging, like 16 pi over 3. Okay? Don't be thrown by that. That just means that we have to go around the unit circle a few times before we're able to draw our location that we know and then find our reference angle. So 16 pi over 3, remember if I'm trying to find a coterminal angle for that, I'm going to subtract 2 pi. Okay, so I'm either going to add or subtract 2 pi as I go around the unit circle. So here we're going to subtract so I can make it smaller, but I don't want to subtract 2 over 1. I want to subtract 6 pi over 3 because I need a common denominator. Okay, so 16 minus 6 is going to be 10 pi over 3. That's still too big. I can't draw that on my unit circle. So I'm going to subtract another 6 pi over 3, and then I'll have 4 pi over 3. Okay, now I know this is my coterminal angle. Okay, and I can draw that on my unit circle now. I know where that is. And if it's over 3, remember that means this top semicircle and the bottom semicircle have been chopped into 3 sections. So 1, 2, 3, 4, 5, 6. Okay, and I'm going to go 4 of them. 1, 2, 3, 4. So there's my 4 pi over 3 right there. Now, my 4 pi over 3 then has a reference angle of pi over 3. So that means that any terminal point here is going to be the same as pi over 3 in the first quadrant. So the terminal point for pi over 3 in the first quadrant was 1/2 square root 3 over 2. Okay, and remember we have cosine and then sine. So I'm going to be dealing with the sine of that coterminal point. So I'm going to have the square root 3 over 2. But I'm in the third quadrant. Remember, all students take calculus. The only thing that's positive in the third quadrant is tangent. I'm dealing with a sine. Sine has to be negative. Okay, so the steps that they recommend here, they say find the reference angle, which we did, determine the sign of the trig function, and then find the value of the trig function. So I kind of flip-flop those 2 steps. Okay, I like to find your reference angle, find your value, and then double check the signage and make sure you have the appropriate positive or negativeness. Okay, so last one, part B, we're finding the secant. Okay, so here's an inverse function now. So remember, secant is going to be 1 over cosine. Okay, so we're going to have that added step in there too. But before I worry about that, I'm going to take a look at this negative pi over 4. This is a negative angle, so that means when I draw my picture, I'm going to go down and to the left. I'm going to go clockwise around my unit circle, but I'm only going down pi over 4, so I'm right here. I'm in the fourth quadrant. But again, that reference angle is really pi over 4, so it has the same terminal points as pi over 4 in the first quadrant, and those terminal points are square root 2 over 2 and square root 2 over 2. Okay, so secant is 1 over cosine. So my cosine value is my x value, so it's the square root 2 over 2. But remember, in my fourth quadrant, all students take calculus. Only cosine and its inverse are going to be positive. Okay, so I'm going to have a positive square root 2 over 2. So I'm really doing 1 over square root 2 over 2. But again, I can't leave my answer like that. I have to rationalize it. So I'm going to multiply by my reciprocal here. So everything cancels now, and I have 2 over the square root 2. I got to get rid of the radical in the denominator. So I'll have 2 square root 2 over 2, and that reduces down to the square root of 2. I can cancel those 2's out in front. Okay? So you can think through basically all of these problems that we did. You can think through them the same way. Find that reference angle, find the terminal point, simplify any algebraic expression you might have, like if it's a fraction or a radical in the denominator, and then make sure you have the appropriate positive or negative sign. Okay, so if this was something that you struggled with a little bit in chapter 5, here's another chance to practice it and get really good at it. and you'll be good at it now for radian measures and for degree measurements. So again, work through these problems. Notice that for 11 through 31, you're just doing every fourth problem. So do 11 and then skip 12, 13, and 14. Do 15 and then skip the next three, and so on and so on. Okay? The odd problems are in the back of the book. The odds and the evens are worked out in the binder in the classroom. And if you have any questions, come on in and see me before school.